Hello everyone. Today we are going to solve the first quiz of Math102. I'm Semih Akkoç.
I am Yusuf Kesmen.
And we are going to try to solve the first quiz problem. So in here we see some exponential factors. So using geometric series might be a good idea. So to see better, we can rearrange those factors. Right now, I am going to get the reciprocal of this 3 to the power n minus 1. So we will get this. Then, if we just take this n minus 1 to n, we will see so it is clear that we have a geometric series right here. So we just need to write what is A and what is R. So since we know the first index is 1, we can just give 2 here, and we get 4 over 9. So 4 over 3 is our A, and R is 3 over 2, 2 over 3. And since absolute value of R is restrictedly smaller than 1, this series converges. Sum is A times 1 over 1 minus R, which is 2
4 over 3.
4 over 3 over 1 minus over 3. So we get 3 and 4. So since we know that this series converges and we find what this series converges to, we finally solve the question. So for second part of the question asks this question, and it's explicit. It wants us to find the infinite sum explicitly. So we see this rational function, which means division of two polynomial functions. So we can use partial fraction decomposition method, and after that we can see how we can try to understand how the pattern goes, or we can use this trick which I'm about to show, and this trick will make our lives easier. We need to add some terms and divide. We need to add and subtract some terms to do this trick. So since we know that we can use this on upstairs, we just do this minus n plus 1. If you ask why we did this, we can explain we want to get this term, but we also want to use these terms upstairs, so we can use some simplification, and after that we can get a telescoping series. Since we know that we can use addition and subtraction on series, infinite series, we just divide the series in two different series, and since we know this is a telescoping series and this is a telescoping series, we find their infinite sum separately. After that, we just subtract their infinite sums and we get the result. So I'm running out of space, but we can understand that I'm just writing this in two different sums. So first I'm going to focus on this. After that, this is also similar. It's similar and I'm running out of space. I might just give the result of it. But it is, we just do this similar thing, just I'm about to do. One may ask why we just split those things like that. So we can explain it with partial fraction decomposition, since we can write this sum as 1 over k minus 1 over k plus 1 with using partial fraction decomposition method. We just use this idea and integrate it in here, and we get this. So this is just since those elements just cancel out, we only get 1 minus 1 over n plus 2 with a factor of 2. So we get this. Also, note that we didn't use this infinite series, we just used till n, because we can't do cancellations on infinite series. We need to convert them into sums. After that, we can do cancellations. Since we know what is Sn, we can take its limit, and since this partial sums limit will be equal to this, we can conclude that if we find this limit, this is also its limit. So this will become 0, since 1 over infinity is 0, and this is simply 2. And other sum is, if we call this as capital A-n, this will come 3 over 4. So since our main sum is basically
minus, I believe.
oh yeah, sorry. And we conclude that this is 5 over 4. So to sum up what we did,
Here is also minus.
oops, sorry, also my mistake. To sum up what we did, we solved this rational function inside an rational sequence. Then we do this trick and we divide this into two telescoping series, which we use this idea from the partial fraction decomposition method, and then we clearly show this. One of the important thing is we didn't do cancellations on serial series, but we did this on partial sums. So we conclude that this comes basically this. Then we take this to the infinity, we take its limit to the infinity, then we get 2. We also did the same thing for the other part. Then we get this as, then we, since we know both of the sums, we just did the math and we get the result.
These are minus, by the way.